And now in this lecture we're going to solve two questions. In the first question we find out the radius of this circle, and in the second question we find out the area of this green shape by using two different methods. So we start with the first question. In the drawing we have quadrilateral ABCD that is described by this circle. AB equals to AD equals to 4, BC equals to 6, CD equals to 8. Again, our task is to find out the radius of this circle. So first of all, we join points B and D together by straight line. By joining points B and D together, those two triangles. So we define this angle, angle DAB is theta. So here we can implement rule 70 in our drawing. Rule 70. According to rule 70, in a cyclic quadrilateral, the sum of the opposite angles is equal to 180 degrees. So in the drawing, we have a circle. Inside this circle, we have quadrilateral ABCD that is described by this circle. And because of the fact that quadrilateral ABCD is a cyclic quadrilateral, the sum of those two opposite angles must be equal to 180 degrees. This is to say, alpha plus beta equals to 180 degrees. Likewise, the sum of those two opposite angles must be also equal to 180 degrees. That is to say, gamma plus delta equals to 180 degrees. So we can implement rule 70 in our drawing. Why put in our drawing? This is, of course, a cyclic quadrilateral. Therefore, the sum of those two opposite angles must be equal to 180 degrees. So theta plus this missing angle, total the sum of those two opposite angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 180 degrees minus theta. Why? Because 180 degrees minus theta plus theta is equal to 180 degrees. That is the sum of those two opposite angles in quadrilateral ABCD. Therefore, this missing angle must be equal to 180 degrees minus theta. So in the next step, we will implement the law of cosines on this triangle, and then we implement the law of cosines in this lower triangle BDC. So we start with the implementation of the law of cosines, this triangle ADB. So repeat quickly on the law of cosines. The law of cosines is true in any triangle. So this is a triangle ABC that could be any triangle. Side AB equals to A units in itself, side AC equals to B units in itself, side BC equals to C units in itself. This is angle BAC is equal to theta degrees in size. So this triangle ABC that could be any triangle, according to the law of cosines, the following equation is true. C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Again, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. And implement the law of cosines in this triangle ABD. According to the law of cosines, this triangle ADB, the following equation is true. BD square equals to DA square plus AB square minus 2 times DA times AB times cosine theta. And again, according to the law of cosines, in this triangle ADB, the following equation is true. BD square equals to DA square plus AB square minus 2 times DA times AB times cosine theta. DB is the missing side, so we have to see this, so it is DB square equals to DA square. DA is 4, therefore DA square is 4 squared, this is 16, plus AB square. AB is also 4, therefore AB square is 4 squared, this is 16, minus 2 times DA, this is 4, times AB, this is also 4, times cosine theta. So in total, according to equation 1, I should find out that BD square equals to 16 plus 16 as 2 times 4 times 4 times cosine theta. So BD square equals to 16 plus 16 is 32, minus 4 times 4 is 16, and 16 times minus 2 is minus 32. So total this expression equals to minus 32 times cosine theta. So according to equation 1, I found out that BD square equals to 32 minus 32 times cosine theta. So in the next step, we will implement the law of cosines. This triangle DBC. In triangle DBC, according to the law of cosines, the following equation is true. DB square equals to DC square plus BC square minus 2 times DC times DB times cosine 180 degrees minus theta. And again, total according to the law of cosines is this triangle DBC, the following equation is true. DB square equals to DC square plus BC square minus 2 times DC times DB times cosine 180 degrees minus theta. So DB square equals to DC square. DC is 8, therefore DC square is 8 squared, that is 64. Plus BC square. BC is 6, therefore BC square is 6 squared, that is 36. Minus 2 times DC, that is 8. Times DB, that is 6. Times cosine 180 degrees minus theta. Actually, we have the trigonometric identity that says that cosine 180 degrees minus theta equals to minus cosine theta. So according to this trigonometric identity, we get that cosine 180 degrees minus theta equals to minus cosine theta. So here we can, so instead of cosine 180 degrees minus theta in this equation, we write down minus cosine theta. So it is cosine theta minus. And minus times minus is plus. So this expression is a positive expression. So according to equation 2, if you found out that dB square equals to 64 plus 36 is 100. Here we have 8 times 6 is 48, and 48 times 2 is 96. So in total, this expression equals to 96 cosine theta. So actually, according to equation 2, we found out that dB squared equals to 100 plus 96 cosine theta. This is according to equation 2. But according to equation 1, we only found out that dB squared equals to 32 plus 32 times cosine theta. So we have two different equations for dB squared. Therefore, we get equation 3 that says that dB squared according to equation 1 must be equal to dB squared according to equation 2. Very simple equation. So dB squared according to equation 1 equals to 32 plus 32 times cosine theta. And it must be equal to dB squared according to equation 2. dB squared according to equation 2 equals to 100 plus 96 times cosine theta. So here we subtract 32 from this equation. So here 32 will get cancelled. And we left only with minus 32 times cosine theta equals to 100 minus 42 is 68. 68 plus 96 cosine theta. So total we found out that minus 42 times cosine theta equals to 68 plus 96 times cosine theta. So here we subtract 96 times cosine theta from this equation. And get that, so here 96 cosine theta will get cancelled. And here we have minus 32 times cosine theta minus 96 cosine theta equals to minus 128 cosine theta. Equals to 68. So here we divide this equation by minus 128 and we get that according to equation 3 cosine theta equals to minus 68 over 128. So here we divide both the numerator and the denominator of this number by 2. We get that minus 68 over 2 is minus 34. And 128 over 2 is 62. It is 64. So here we have minus 34 over 64. Here we divide this expression also both the numerator and the denominator of this expression by 2. We get that minus 34 over 2 is minus 17. And 64 over 2 is 34. So in total we found out that cosine theta equals to minus 17 over 34. And again, in total we found out that cosine theta equals to minus 17 over 34. we have the trigonometric identity that says that sinus squared theta plus cosine squared theta equals to 1. Here we subtract cosine squared theta from this equation and get that sinus squared theta equals to minus cosine squared theta. So here we take a root out of this equation and finally get that sinus theta equals to the square root of 1 minus cosine squared theta. And again, in total, we should find out that sinus theta equals to the square root of 1 minus cosine squared theta. But we already found out that cosine theta equals to minus 17 over 34. Therefore, cosine squared theta must be equal to minus 17 over 34 squared. And minus 17 over 34 squared is equal to actually it is email 64 over 2 is 32. Not 32, it's not 34 but 32. Again, 64 over 2 is 32. And therefore cosine theta equals to 17 over 32. And cosine theta equals to minus 17 over 32. Again, cosine theta equals to minus 17 over 32. Therefore cosine squared theta equals to minus 17 over 32 squared. And minus 17 over 32 squared is equal to 0.2822. And again, in total, we should find out that cosine squared theta equals to 0.2822. Therefore, we can substitute cosine squared theta in this trigonometric identity by 0.2822. We do it now and get that sinus theta equals to the square root of 1 and cosine squared theta equals to 0.2822. 1 minus 0.8 minus 0.2822 equals to 0.7177. So sinus theta equals to the square root of 0.7177. And the square root of 0.7177 is equal to 0.7177 0.847. So sinus theta equals to 0.847. And what is the value of BD? The value of this code BD. We already found out that BD square this BD square equals to 32 minus 32 times cosine theta. BD square equals to 32 minus 32 times cosine theta. And cosine theta equals to 0.2822. So if you want to know that BD square equals to 32 minus 32 times 0.2822. So BD square in total equals to 32 and minus 32 times 0.288 is equal to 17. Actually, cosine theta equals to 17 over 32. So BD square equals to, write it down again, we found out that BD square equals to 32 minus 32 times cosine theta. So BD square equals to 32 minus 32 times cosine theta. And cosine theta is 117 over 32. Here we have minus times minus is plus. So this expression in total is a positive expression. We have 32 in the numerator, 32 in the denominator, so 32 get cancelled. Here again, minus times minus is plus. So total dB square equals to 32 plus 17 is 49. So dB square equals to 49 You take out all those equations. Here the dB is equal to the square root of 4937. So in total, we found out that the length of this side dB is equal to 7 units. And we already found out that sin theta equals to 0.847. Side dB equals to 7 units in Islam. And sinus theta equals to 0.847. So the next step, we will implement the law of sines in this triangle DBC. Implement the law of sines, this triangle ADB. This upper green triangle ADB. So please click on the law of sines. The law of sines is true in any triangle. This is triangle ABC that could be any triangle. Triangle ABC is described by this circle. Of this circle blocks triangle ABC. AB equals to C units in its length, AC equals to B units in its length, BC equals to A units in its length. This angle BAC is equals to capital A degrees in size. This is angle ACB that is equals to capital C degrees in size. This is angle ABC is equals to capital B degrees in size. So in this triangle ABC that could be any triangle, according to the law of sines, the following equation is true. A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the radius of this circle that blocks triangle ABC. So repeat again, according to the law of sines, the following equation is true. A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. We can implement the law of sines in our drawing. This is triangle ABD. Triangle ABD is definitely inscribed by the circle. Why? Because of the fact that all the three vertices A, D, and B lie in the circle itself. Therefore, the green triangle is inscribed by the circle. Therefore, we can implement the law of sines in its full version. According to the law of sines in its full version, dB over sinus theta equals to 2R. Again, dB over sinus theta equals to 2R. And now is the radius of this circle that blocks triangle ABC. Again, triangle ABC. So according to the law of sines, the green triangle ADB, the following equation is true. The green triangle ADB dB over sinus theta equals to 2R. And R is the radius of this circle that blocks triangle ABC. It is also the radius that we are looking for in this question. So according to the law of sines, dB over sinus theta equals to 2R. dB7 over sinus theta is 0.847 equals to 2R. 7 over 0.487 is equal to 8.2644 equals to 2R. So here we divide this equation by 2 and find that R, that is the radius that we are looking for this question, is equal to 14 r equals to 4.132 units in Islam. And again, to that we found out that the radius of this circle, that is the radius that we are looking for in this question, is equal to 4.132 units in Islam. Okay, so we finished the first question. In the next step, I'll present you the second question of this lecture, and we'll solve the second question by using two different methods. In this second question, our task is to find out the area of this green shape. The green shape is actually triangle APC. So we have to find out the area of this green triangle APC. So in the moment, we have the big right triangle ABC. This angle ACB is equal to 2 theta degrees in size. This angle ABC, this is the right angle. Line 70 AP equals to 5 units in itself. Line 70 PB equals to 4 units in itself. Again, our task is to find out the area of this green shape. So first of all, we will do a construction. That is to say, from point P, we will go perpendicular on AC. So this angle equals to 90 degrees in size, and this angle also equals to 90 degrees in size according to our construction. We define the touching point of the perpendicular from point P, and AC this point is point Q. We focus on the big right triangle ABC. In the big right triangle ABC, this angle equals to 2 theta, this angle equals to 90 degrees, and therefore this missing angle must be equal to 180 degrees minus 2 theta. According to the rule that says that the sum of the angles in the triangle is equal to 180 degrees. So this angle equals to 2 theta, this angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus 2 theta. Why? Because 90 degrees minus 2 theta plus 2 theta is 90 degrees. 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in a triangle. Likewise, in this triangle, lower triangle PBC, this angle equals to theta, this angle equals to 90 degrees, and therefore this first missing angle must be equal to 90 degrees minus theta. According to the sum rule that says that the sum of the angles in any triangle is equal to 180 degrees. Likewise, in this triangle QPC, this angle equals to theta. This angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus theta according to the sum rule. The sum of the angles in a triangle is equal to 180 degrees. So what is the size of this missing angle? APQ. Okay, again, what is the size of this missing angle? APQ. According to the rule that says that the sum of the angles on one side of a straight line is equal to 180 degrees, you get that this missing angle APQ must be equal to 180 degrees minus 2 times 90 degrees minus theta. So the missing angle APQ must be equal to 180 degrees minus the sum of those two angles, according to rule 3. So it is 180 degrees. What is the sum of those two angles? Because of the fact that those two angles are identical, it must be equal to 2 times 90 degrees minus theta. The sum of those two angles is 2 times 90 degrees minus theta. So in total, the size of this PQ is equal to 180 degrees minus the sum of those two angles, that is actually 2 times 90 degrees minus theta. So the size of this missing APQ is equal to 180 degrees minus 2 times 90 degrees minus theta. Here we'll open the brackets and get that minus 2 times 90 degrees minus 180 degrees minus 2 times minus theta is plus 2 theta. Minus 180 degrees minus 180 degrees is 0, so we're left only with 2 theta. In total, we should find out that the size of this missing APQ is equal to 2 theta. The missing APQ equals to 2 theta. Two theta degrees in size. In the next step, we'll prove that those two adjacent triangles can go into each other according to angle side angle rule. Then again, we'll prove that the upper green triangle PQC can go into this lower right triangle PBC. Prove that those two right triangles can go into each other according to angle side angle rule. That is to say, we prove that the green triangle PQC, the green right triangle PQC can go into this right lower triangle PBC. So why those two right triangles can go into each other? First of all, those two angles are both equal to theta and therefore they are equal to each other. So actually, this is angle QCP in the upper green triangle PQC, and it equals to this angle, actually angle PCB, in the lower right triangle PBC. So I should know that angle QCP in the upper green triangle is equal to angle PCB in the right lower triangle PCB. They are both equal to theta and therefore they are equal to each other. In addition, this is side PC, that is a common angle that belongs to both triangles. So we can write down that PC equals to itself as a common side that belongs to both triangles. So in other words, PC equals to itself as a common side that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta and therefore they are equal to each other. So actually this is angle QPC. The upper green triangle QPC, and it's equals to this angle, the angle CPB. The lower right triangle PBC. Repeat again. And we found out that angle QPC in the upper right rectangle PQC is equal to angle CPB in the right lower triangle PBC. They are both equal to 90 degrees on theta, and therefore they are equal to each other. And therefore, if you found out that the green upper triangle PQC congruent, this is the side congruent to the lower right triangle PBC according to angle side angle rule. That is to say, we found out that those two angles and the side that is included between those two angles in the green triangle PQC are corresponding equal to those two angles and the side that is included between those two angles in the white triangle PBC. Therefore, those two right triangles can go into each other according to angle side angle rule. We have those two angles and the side that is included between those two angles in this green triangle are corresponding equal to those two angles, and the side that is included between those two angles, that is side PC, is the right triangle. Therefore, those two right triangles can go into each other according to angle side angle rule. And from the fact that those two right triangles can go into each other, we derive that their corresponding sides must be equal to each other in their lengths. According to the rule that corresponding sides and right triangles are equal to each other. So, that is to say, PB equals to PQ. PB equals to PQ. Why PB is the corresponding side to PQ? Because of the fact that side PB is located in front of angle theta, likewise side PQ also is located in front of angle theta. Therefore, PB is the corresponding side to PQ. But it is given as a equation that PB equals to 4, so if you write it that PB equals to 4, and from this equation 4 equals to PB equals to PQ, we derive that PQ also equals to 4 units in its length. This is side PQ, this equals to 4 units in its length. It is very easy to see that the big triangle ABC is similar to this small triangle APB. But again, it's very easy to see that the big triangle ABC is similar to this small green triangle APQ. Why those two triangles are similar to each other? First of all, this is angle A, this is the common angle that belongs to both triangles. So you can write down that this angle equals to itself is the common angle that belongs to both triangles. Those two angles are both equal to 90 degrees and therefore they are equal to each other. And finally, those two angles are both equal to theta and therefore they are equal to each other. So we should find out that all the three angles of this big right triangle ABC are corresponding equal to all the three angles of this small right triangle APQ. Therefore, those two right triangles are similar to each other according to angle similarity rule. So it is now I should find out that the big right triangle ABC is similar this is the sign of similar to this green small right triangle APQ according to angle similarity rule. Because again, we have to find out that the big right triangle ABC is similar to the small green triangle APQ according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we know that the following relationship exists between their sides. We have that AP, side AP, the small green triangle APQ, or side AC in the big right triangle ABC is equal to side PQ in the green right triangle APQ, or side BC of the big right triangle ABC. And again, from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We derive that side AP in the green small triangle APQ, or side AC of the big right triangle ABC is equal to side PQ of the green small right triangle APQ, or side BC in the big right triangle ABC. AP is 5 over AC. We define side AC as A. So AC is A, and this was to PQ. PQ is 4 over BC. We define BC as B. So in total, we found out that 5 over A equals to 4 over B. Here we cross multiply this equation. I get that 5B equals to 4A. This is to say, if we define A, if A equals to 5x, then we get that 5B equals to 4 and A equals to 5x, so it solves A by 5x. So I should find out that 5 equals to 4 times 5 times x. Here we divide this equation by 5. 5 get cancelled. In total, we should find out that 5 will get cancelled. So in total, b equals to 4x. And again, we should divide this equation by 5, so 5 will get cancelled. So in this side of the equation, we left with b equals to 4x. So in total, we should find out that if a equals to 5x, then b equals to 4x. So if a equals to 5x, then b equals to 4x. The next step, we will implement the Pythagoras theorem on this big triangle, triangle ABC. Okay, again, we will implement the Pythagoras theorem on this big triangle, triangle ABC. Here by PT is the relation for Pythagoras theorem. So according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in this big triangle, the big right triangle ABC, according to the Pythagoras theorem, we get that AC square, that is the square of the hypotenuse, equals to AB square plus BC square. So, according to the Pythagoras theorem, the big right triangle ABC, AC square, that is the square of the hypotenuse, equals to AB square plus BC square. AC equals to 5x, and therefore AC squared equals to 5x squared, that is 25x squared. and is equal to AB squared. AB is 5 plus 4, that is 9, therefore AB squared is 9 squared, that is 81. Plus BC squared. BC is 4x, therefore BC squared is 4x squared, it is 16x squared. So then we found out that 25x squared equals to 81 plus 16x squared. Here we'll subtract 16x squared from this equation. And get here 16x squared gets cancelled. Here, on the other side of the equation we have 25x squared minus 16x squared is 9x squared. So 9x squared equals to, on the other side of the equation we have to leave 81. 9x squared equals to 81. Here we divide this equation by 9. We get that x squared equals to 81 over 9 is 9. X squared equals to 9. Here we take out of this equation. We get that x equals to the square root of 9, that is 3. So today we found out that x equals to 3 is in its term. B equals to 4x. X is 3, therefore 4x is 3 times 4, that is 12. So B is equals to 12. Likewise, A is equals to A equals to 5x. X is 3, so 5x is 5 times 3, that is 15. Our test is to find out the area of this green shape. So what is the area of this green shape? What is the green shape? The green shape is actually triangle APC. The green shape is triangle APC. So we have to find out the area of triangle APC. What is the area of the green triangle APC? The area of green triangle equals to the base of the triangle times the height of the base over 2. It's the base times the height over 2. It shows the base of this entire APC, SAP, and the height of the base is BC. Why BC is the height of the base? Because of the fact that BC creates 90 degrees with AP. Again, BC creates 90 degrees with the extended AP. The extended AP is AP. This angle is a right angle. So the height of the base is BC divided by 2. AP is 5 according to what is given as the question. Times BC. We just right now found out that BC equals to 12. Divided by 2. 5 times 12 is 60, and 60 over 2 is 30. 30 square units in its size. So if you found out that we have this green shape is equal to 30 square units in its size. We have another way to find out the area of this green shape. We choose the base SAC. The base is AC. The height of the base must create 90 degrees with the base. PQ definitely creates 90 degrees with the base AC, because it is a right angle. So the height is PQ. over 2. AC equals to 15. Times PQ. PQ is 4 over 2. 15 times 4 is 60, and 60 over 2 is 30. So today we found out that the area that we are looking for this question, that is the area of this relationship, is equal to 30 square units in size. So we finish with the first method. In the next step, I present to you how to find out the area of this relationship according to a second method. This is point C, of course. We'll focus on this lower right angle PBC. This white lower right angle PBC it is very easy to see that tangent theta equals to PB over BC. And again, in the right angle PBC, it is very easy to see that tangent theta equals to PB over BC. We define BC as B. So total tangent theta equals to PB. PB is 4 over BC. BC is B. So in total, if we found out that according to equation 1, tangent theta equals to 4 over B. In the next step, we focus on the big right angle ABC. On the big right angle ABC, it is very easy to see that tangent to theta equals to AB over BC. And again, the big right angle ABC, tangent to theta equals to AB over BC. AB is 5 plus 4, that is 9. Over BC. BC is B according to our definition. So those two sides of the equation are equal to each other. That is to say, according to equation 2, times 2 theta equals to 9 over B. This is according to equation 2. But according to equation 1, we found out that tangent theta equals to 4 over B. We have the trigonometric identity. It states that tangents 2 theta equals to 2 times tangent theta over 1 minus tangent square theta. And again, we have trigonometric identity that says that tangent 2 theta equals to 2 tangent theta over 1 minus tangent square theta. Here we substitute this trigonometric identity, tangent 2 theta by 9 over b is equal to 2 tangent theta. Substitute tangent theta by 4 over b. So it is 2 times 4 over b over 1 minus tangent square theta. If tangent theta equals to 4 over b, it means that tangent square theta equals to 16 over b square. So minus tangent square theta equals to minus 16 over b square. So to them found out that according to equation 3, 9 over b equals to 2 times 4 over b over 1 minus 16 over b square. Here we cross multiply this equation, and we get that according to equation 3, nine over b times 1 minus 16 over b square equals to 2 times 4 is 8, so this expression equals to 8 over b. So in total, according to equation 3, we found out that nine over b times 1 minus 16 over b square equals to 8 over b. So here we have b square on both sides of this equation, so b square will get cancelled. After we cancel b square on the side of the equation, we left only with 9 times 1 minus 16 over b square. And on the other side of the equation, we left only with 8. Here we'll open the brackets on this side of this equation, equation 3, and get that according to equation 3, 9 times 1 is 9. Here we have 9 times minus 16 is minus 144 over b square. Equals to 8. Here we'll subtract 8 from this equation, equation 3. And get that according to equation 3, nine minus 8 is 1, minus 144 over b square equals to 0. Here we add 144 over b square to the equation, equation 3. So here 144 over b square will get cancelled. So here we left only with 1 equals to 144 over b square. Here we multiply this equation by b square. If I get it according to equation 3, b square equals to 144. So here we take out this equation. If I get that b equals to the square root of 144, that is 12. So b equals to 12 units in Islam. B is equals to b, and b equals to 14 and 12 units in Islam. Our task is to find out the this relationship. What is there of the green shape? The green shape is actually triangle APC. Again, the green shape is triangle APC. So our test is to find out the area of this red triangle APC. But we know that the area of any triangle equals to the base of the triangle times the height to the base over 2. The height must rest with the base. We choose the base SAP. The height to the base must rest with the base or must rest with the extended base. The extended base AP is AB. AB is the extended base. BC definitely rests with AB, because this is the right angle. So the height to the base is BC. Over 2. So here we have AP is 5 times BC, BC is B over 2. So then we found out that the area of this green shape equals to 5B over 2. But we only found out that B equals to 12. So we substitute B by 12. So it is 5 over 2 times 12. 5 times 12 is 60, and 60 over 2 is 30. So it is in size. So on both methods, we found out that the area of this green shape, that is the area that we are looking for this question, is equal to 30 square inches in size. So finish with the second question, the second method of the second question. So in the next step, after the lecture, we start with the repetition of the first question, and then we repeat on the both methods of the solution of the second question. In the first question, our task is to find out the radius of this circle that blocks quadrilateral ABCD. We can say also quadrilateral ABCD is described by this circle, and our task is to find out the radius of this circle. It's given us a question that AB equals to AD equals to 4, DC equals to 8, and BC equals to 6. So our task is to find out the radius of this circle. So first of all, define the size of this angle BAD is theta. So here we can implement rule 70. According to rule 70, in a cyclic quadrilateral, the sum of the opposite angles is equal to 180 degrees. Quadrilateral ABCD is of course a cyclic quadrilateral because of the fact that it is described by this circle. Therefore, we can implement rule 70. According to rule 70, the sum of those two opposite angles must be equal to 180 degrees. This is angle theta according to our definition. Therefore, this means angle must be equal to 180 degrees minus theta according to rule 70. Why? Because of the fact that 180 degrees minus theta plus theta is 180 degrees. This is the sum of the angles, the sum of the opposite angles of a quadrilateral that is described by a circle. Therefore, this means angle must be equal to 180 degrees minus theta according to rule 3. In the next step, we join points B and D together by straight line. By joining points B and D, we divided quadrilateral ABCD into two triangles. We have the big triangle AB, the small great triangle ABD, and the big triangle BDC. So in the next step, we implemented the law of cosines on both triangles. In the first step, we implemented the law of cosines in this green triangle ABD. In the second step, we implemented the law of cosines this white triangle BDC. So repeat quickly of the law of cosines. The law of cosines is for any triangle. This is triangle ABC that could be any triangle. Side AB equals to A in itself, side AC equals to B in itself, side BC equals to C in itself. This is again BAC that equals to theta degrees in size. So in this triangle ABC that could be any triangle, according to the law of cosines, the following equation is 2. C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Again, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. So in the first step, we implemented the law of cosines on this green triangle, triangle ABD. According to the law of cosines, this green triangle ABD, the following equation is 2. BD squared equals to DA squared plus AB squared minus 2 times AD times AB times cosine theta. And again, this green triangle ABD, according to the law of cosines, the following equation is 2. BD squared equals to AD squared plus AB squared minus 2 times AD times AB times cosine theta. BD is the missing side, so it is. And it is equals to AD squared. AD is 4, therefore AD squared is 4 squared, that is 16, plus AB squared. AB is also 4, so AB squared is 4 squared, that is 16, minus 2 times AD, that is 4 times AD, that is also 4 times cosine theta. So in total, according to the law of cosines, we have found that BD squared equals to 16 plus 16 minus 2 times 4 times cosine theta. So BD squared equals to 16 plus 16 is 32, and 4 times 4 is 16, and 16 minus 2 is minus 32 times cosine theta. So in total, according to equation 1, we found out that BD squared equals to 32 minus 32 times cosine theta. In the next step, we implemented the law of cosines in this triangle by an ABD. According to the law of cosines in this triangle ABD, BD squared equals to BC squared plus CD squared minus 2 times BC times AD times cosine 180 degrees on theta. And again, this triangle ABD, DBC, according to the law of cosines, the following equation is 2. dB squared equals to DC squared plus BC squared minus 2 times DC times dB times cosine 180 degrees on theta. We have the trigonometric identity that says that cosine 180 degrees on theta equals to minus cosine theta. Therefore, we can substitute cosine 180 degrees on theta in this equation by minus cosine theta. We did it and we found out that dB squared equals to DC squared. DC is 8, therefore DC squared is 8 squared, that is 64, plus BC squared. BC is 6, therefore BC squared is 6 squared, that is 36, minus 2 times DC, that is 6, times DC, that is 8, times BD, that is 6, times cosine 180 degrees minus theta. But cosine 180 degrees minus theta is minus cosine theta. So we have minus times minus is plus. So this expression in total is a positive expression. So in total we found out that according to equation 1, dB squared equals to 32 minus 32 times cosine theta. According to equation 2, we have here dB squared equals to 64 plus 36 is 100. Here we have 8 times 6 is 48, and 48 times 2 is 96. So total this expression equals to 96 cosine theta. So total according to equation 2, we found out that dB squared equals to 100 plus 96 times cosine theta. So we have two different equations for cosine theta, for dB squared. Therefore, created equation 3 that says that dB squared according to equation 1 must be equal to dB squared according to equation 2. dB squared according to equation 1 equals to 32 minus 32 times cosine theta. It must equal to dB squared according to equation 2. dB squared according to equation 2 equals to 100 plus 96 times cosine theta. So here we substitute 32 for this equation. So here 32 gets cancelled. The left only minus 32 times cosine theta equals to 100 minus 32 is 68 plus 96 times cosine theta. So here we added substitute 96 cosine theta for this equation 3. So here 96 cosine theta will get cancelled. And we left only with 68. And on the other side of the equation we have minus 32 cosine theta minus 96 cosine theta is equal to minus 128 cosine theta equals to 68. Here we divide this equation by 128. We found out that cosine theta equals to minus 68 over 128. Here we divided both the numerator and the numerator of this expression by 2. Minus 68 over 2 is 34, and 128 over 2 is 64. We divided both the numerator of this expression by 2. 34 over 2 is 17, and 64 over 2 is 32. Those two sides of the equation are equal to each other. That is to say, in total, we found out that cosine theta equals to 17 over 32. We have the trigonometric identity that says that sinus squared theta plus cosine squared theta equals to 1. Here we substitute cosine squared theta for this equation, and we found out that sinus squared theta equals to 1 minus cosine squared theta. Here we took out of this equation, out of this trigonometric identity, and we found out that sinus theta equals to the square root of 1 minus cosine squared theta. But we already found out that cosine theta equals to 17 over 33. If cosine theta equals to minus 17 over 33. If cosine theta equals to minus 17 over 33, it means that cosine squared theta must equal to minus 17 over 32 squared. The value of this expression is 0.2822. So in total we found out that cosine squared theta equals to 0.2822. And we already found out that sinus theta equals to the square root of 1 minus cosine squared theta. But cosine squared theta is 0.2822. So sinus cosine squared theta in this equation by 0.2822. So sinus theta equals to the square root of 1 minus 0.2822 is equals to 0.7177. So total, if we found out that sinus theta equals to the square root of 0.7177, and the square root of 0.7177 is actually 0.847. So in total, we found out that sinus theta equals to 0.847. What is the value of BD? According to equation 3, the first equation, we only found out that dB squared equals to 32 minus 32 times cosine theta. So dB squared equals to 32, and again, we found out that dB squared equals to 32 minus 32 times cosine theta. So dB squared equals to 32 minus 32 times cosine theta. And 32 and cosine theta equals to minus 17 over 32. So in total we found out that dB squared equals to 32. here minus times minus is plus. So this expression is a positive expression. We have 32 in the numerator, 32 in the denominator, so 32 get cancelled, and the left only with 17. So in total, if you found out that dB squared equals to 32 plus 17 is 49. dB squared equals to 49, you have to go out of the equation. If I found out that dB equals to the 4 to 49, that is 7. So dB equals to 7 units in exact. dB squared equals to 7 units in exact. And we already found out that sinus theta equals to 0.847. And sinus theta equals to 0.847. The next step, we implemented the law of sines of this rectangle times ADB. Repeat quickly of the law of sines. So in the drawing, we have triangle ABC, it is described by this circle. AB equals to 3 units in its half, AC equals to B units in its half, BC equals to A units in its half. This is again BAC, this is equals to capital E degrees in size. Likewise, this is again CB, this is equals to capital C degrees in size. And finally, this is again ABC, this is equals to capital B degrees in size. So according to the law of sines, this triangle ABC that could be any triangle, the following equation is to A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the radius of this circle that blocks triangle ABC. Repeat again, according to the law of sines, the following equation is to A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. So we can implement the law of sines in its full version. Because the law of sines is to without the circle that blocks triangle ABC. We implement the law of sines in its full version. And triangle ABC is described by this circle. So first of all, this is the rectangle ABC that is definitely described by this circle. Why? Because of the fact that all the three vertices A, B, and D lie in the circle itself. Therefore, we can implement here the law of sines in its full version. So according to the law of sines in its full version, in this rectangle ABD, BD over sinus theta equals to 2R. Again, BD over sinus theta equals to 2R. According to the law of sines, in the rectangle ADB, the following equation is to BD over sinus theta equals to 2R. R is the radius of the circle that we are looking for in this question. BD is 7, sinus theta is 0.847, so 7 over 0.847 is equal to 8.2644 equals to 2R. If we divided the equation by 2, and found out that R equals to 8.2644 over 2, that is 4.132 units in its length. So in total, we should find out that the radius of this circle, that is the radius that we are looking for in this question, is equal to 4.132 units in its length. So we finish to repeat on the first question. In the next step, I repeat on the solution of the second question on both methods. Our task in the second question is to find out the Abelian shape. So in the drawing, you have the big triangle ABC. You know that this is the right angle. those two angles are both equal to theta. Therefore, angle ACB equals to 2 theta. AP equals to 5 units in itself, PB equals to 4 units in itself. Again, our test is to find out the area of this ring shape. So first of all, we did the construction, that is to say, from point B we do perpendicular on AC. Again, from point B we do perpendicular on AC. So this angle equals to 90 degrees inside, this angle also equals to 90 degrees inside according to our construction. We define the touching point of the perpendicular from point B and AC. This point is point Q. The next step we focus on the big triangle ABC. The big right triangle ABC. This angle equals to 90 degrees inside. This angle equals to 30 degrees inside. Therefore, this first angle must be equal to 90 degrees minus theta. Y equals 90 degrees minus theta. 90 degrees minus 2 theta. Y equals 90 degrees minus 2 theta plus 2 theta equals to 90 degrees. And 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. Therefore, this first angle must be equal to 90 degrees minus 2 theta. Likewise, in this y triangle PBC, this angle equals to theta. This angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus theta according to the sum rule that says that the sum of the angles in any triangle is equal to 180 degrees. Likewise, this great triangle PQC, this angle equals to theta. This angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus theta according to the sum rule. So in the next step, we shall prove that those two right triangles can go to each other according to angle sine angle rule. That is to say, we prove that the green triangle PQC can go to this white triangle PBC according to angle sine angle rule. So why those two right triangles can go to each other? First of all, those two angles are both equal to 90 degrees and therefore they are equal to each other. In addition, this is side PC. That is a common side that belongs to both angles. We can write down that side PC equals to itself. It's a common side that belongs to both angles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So then we found out that those two angles and the side that is included between those two angles, that is side PC, and this great triangle PQC are corresponding equal to those two angles, and the side that is included between those two angles, this right triangle PBC. Therefore, those two right triangles can go to each other according to side angle side rule. We have those two angles and the side that is included between those two angles. This right triangle corresponding equals to those two angles, and the side that is included between those two angles in this right triangle PBC. Therefore, those two right triangles can go to each other according to angle side angle rule. And again, in total, we found out that the green right triangle PQC can point, this is the sign of point, to the white right triangle PBC according to angle side angle rule. And from the fact that those two right triangles can point to each other, we will derive that their corresponding sides must be also equal to each other in the length, according to the rule that says that corresponding sides and right triangles are equal to each other. Those two triangles can point to each other, therefore their corresponding angles must be also equal to each other in the length. Therefore, PB equals to PQ. PB is the corresponding side of PQ because of the fact that PB is in front of angle theta, likewise PQ is also in front of angle theta. So, PB equals to PQ. PB equals to PQ. But it is given as the question that PB is 4, so can I give that PB is 4? So for this equation, 4 equals to PB equals to PQ, without that PQ also equals to 4 units instead. This is the missing side PQ, equals to 4 units instead. From the drawing, it is very easy to see that the big triangle ABC is similar to this small green triangle APQ. Why the big triangle ABC is similar to this small green triangle APQ? Because of the fact that those two angles are both equal to 90 degrees and therefore they are equal to each other. In addition, those two angles are both equal to 2 theta and therefore they are equal to each other. And finally, this is angle 8, this is the common angle that belongs to both triangles, so we can write down that angle 8 equals to itself as a common angle that belongs to both triangles. So in total, we found out that all the triangles of the big right triangle ABC correspond equal to all the triangles of this grand small triangle APQ. Therefore, those two right triangles are similar to each other according to angle similarity rule. So repeat again, in total, we found out that the big right triangle ABC is similar, this is the sign of similar, to the small grand triangle APQ according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side AP of the small triangle or side AC of the big triangle equals to side PQ of the small triangle or side BC of the big triangle. And again, from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side AP of the big triangle or side AC of the side AP of the small triangle or side AC of the big triangle equals to side PQ of the small triangle or side BC of the big triangle. AP is 5 over AC. Define AC as A and it equals to PQ. PQ is 4 over BC. Actually, we define BC as B. So total, we found out that 5 over A equals to 4 over B. Here we cross multiply this equation, and when we found out that 5B equals to 4A. What is the meaning of this equation 5B equals to 4A? It means that if A equals to 5x, let us say, we substitute A by 5x, and we get that 5B equals to 4 times B, and B is 5x. So total 5B equals to 4 times 5 times x. We have 5 on both sides of this equation, so 5 will get cancelled. After cancelled 5, in this side of the equation we have to leave v, while on the other side of the equation we have to leave 4x. So in total, we found out that b equals to 4x. So in total, we found out that if a equals to 5x, then b must be equal to 4x. So if a equals to 5x, then b equals to 4x. The next step, implement the Pythagoras theorem on this big right triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the opposite equals to the sum of the squares of the perpendicular. So, in this big right triangle ABC, according to the Pythagoras theorem, AC squared, that is the square of the opposite, equals to AB squared plus BC squared. And again, the big triangle ABC, according to the Pythagoras theorem, AC squared, that is the square of the opposite, equals to AB squared plus BC squared. AC is 5x, therefore AC squared is 5x squared, is 25x squared, and this equals to AB squared. AB is 5 plus 4, that is 9, therefore AB squared is 9 squared, that is 81, plus BC squared. BC is 4x, therefore BC squared is 4x squared, that is 16x squared. BC is 4x, therefore BC squared is 4x squared, that is 16x squared. And to that, we should find out that 25x squared equals to 81 plus 16x squared. Here we subtract the 16x squared from this equation, so 16x squared is cancelled here, we left here only 81. Here 25x squared minus 16x squared is 9x squared. So in total we found out that 9x squared equals to 81. Here we divided this equation by 9 and found out that x squared equals to 81 over 9 is 9, so x squared equals to 9. Here we took all of those equations and found out that x equals to the square root of 9, that is 3, so x equals to 3, and it's 9. Our task is to find out the of this green. What is the green shape? The green shape is actually the green right triangle ABC. So our task is to find out the green shape, and the green shape is the green right triangle ABC. What is the area of the green triangle ABC? Actually, we know that the area of any triangle equals to the base of the triangle times the height over to the base over 2. Because again, the area of any triangle equals to the base of the triangle times the height to the base over 2. we choose the base of this ABC is AP, and the height to the base is BC. Why the height to the base is BC? Because of the fact that the height BC right 90 degrees with the extended base AP. The extended base AP is AB. This is the right angle. Therefore, BC is the height to the base. And again, the area of the green shape equals to the area of the green triangle ABC. The area of the green triangle APC equals to the base times the height over 2. The base is AP according to our choice. Therefore, the height must be BC over 2. AP is 5 times BC. BC is B divided by 2. So if you found out that the area of the green shape equals to the base AP times the height BC over 2. AP is 5, BC equals to 4 to B, and B equals to 4x. X is 3, therefore 4x is 4 times 3, this is 12. So in total BC equals to 12. BC equals to 12. AP equals to 5, BC equals to 12 over 2. 5 times 12 is 60, and 60 over 2 is 30. So if you want to know that the area of this green shape equals to 30 squares in size. We calculated the area of this green shape in another way. Choose the base SAC, and that to the base is QP over 2. Again, we choose the base of the entire APC SAC, that to the base is PQ over 2. AC is 5x. 5x is 3, so 5x is 5 times 20, this is 15. Times the height to the base is QP, that is 4 over 2. And again, the base AC is 15 times the height to the base PQ, that is 4 over 2. 15 times 4 is 16, 60 over 2 is 30. So in both methods, we found out that the area of this green shape is equal to 30 squares in size. So in the next step, I presented to you how to find out the area of this green shape according to the second method. Focus on this angle PBC. This angle PBC times theta equals to PB over BC. And again, the angle PBC times theta equals to PB over BC. PB is 4. We define BC as B. Again, PB is 4 according to what is given as the equation. BC is equals to B according to our definition. So in total, we should found out that according to equation 1, tangens theta equals to 4 over B. Next step, we focus on this big right triangle BC. This big triangle BC, it is very easy to see that tangens to theta equals to AB over BC. And again, the big triangle BC, it is very easy to see that tangens to theta equals to AB over BC. AB is 5 plus 4, this is 9, over BC. BC is B. Again, so if you know that tangens to theta equals to 9 over B. And tangens to theta equals to AB over BC. AB is 9, over BC is B. So total, if you found out that tangens to theta equals to 9 over B, this is according to equation 2. Well, according to equation 1, we only found out that tangens theta equals to 4 over B. We have the trigonometric identity that says that tangens to theta equals to 2 tangens theta over 1 plus tangens square theta. So here, substitute tangens to theta, this trigonometric identity by 9 over B, and substitute tangent theta this equation by 4 over b. So tangent 2 theta is 9 over b, and it equals to 2 times tangent theta. So it is 2 times 4 over b. Tangent theta is 4 over b over 1 minus tangent square theta. Tangent theta is 4 over b, therefore tangent square theta is 4 over b squared. So 4 over b squared equals to 4 square over 4 square is 16 over b square. Okay, so 2 times tangent theta is 2 times 4 over b or 1 minus tangent square theta. So it is 1 tangent theta is 4 over b, therefore tangent square theta is 4 over b squared. 4 over b squared is 16 over b squared. So total minus tangent square theta is equal to minus 16 over b squared. Here of course multiply this equation, so I found out that nine over b times 1 minus 16 over b, 9 over b times 1 minus 16 over b square equals to 8 over b. We have b on both sides of the equation, so b increases, so the increases b. In this side of the equation we have to leave with 9 times 1 minus 16 over b square. On the other side of the equation we have to leave with 8. So we open the brackets here. We have here 9 times 1 is 9, and here we have 9 times 16 is 144 over b square equals to 8. Here substitute 8 from this equation, 509 plus 8 is 1 equals to 116 x square over b square equals to 0. So here we did actually we know that we have here actually we have here 9 minus 144 over b square equals to 8. So we subtract 8 from this equation, so here we're left with 0, and on the other side of the equation we have 9 minus 8 is 1 equals to 144 over b square. So total we found out that 1 minus 144 over b square equals to 0. So here we added 144 over b square to this equation. So here we left only with 1, and on the other side of the equation we have 144 over b square. Here we multiply this equation by b square, and find out that b square equals to 144. Here to go to this equation, we found out that b equals to the square root of 144, that is 12. So b equals to 12 units in its length. BC equals to b, and b equals to 12 units in its length. Our task is to find out the area of this green shape. The green shape is actually the green triangle ABC. Therefore, the area of the green shape is the area of this green triangle APC. Choose the base of this green triangle SAP and the height as BC. BC creates 90 degrees with the extended base AC. Why? Because this is right angles. Therefore, the area of this green shape equals to the base AP times the height of the base, that is CB over 2. So the area of the green shape is the area of the green triangle ABC. We know that the area of green triangle is equals to the base of the triangle times the height of the base over 2. Choose the base SAP, the height of the base of SBC over 2. So AP equals to 5 times BC equals to B divided by 2. But we only found out that B equals to 12, so we substitute B by 12, and we found out that the area of this green shape, that is the area that we are looking for, is equal to 5 times 12 is 60, and 60 over 2 is 30. So on both methods we found out that the area of this green shape is equal to 5 30 square units in size. And again, I shall find out that the base AP is 5 times the base times the height of the base is BC, that is B over 2. So there the ratio equals to 5 B over 2. B is 12, so substitute B by 12, so in total we have 5 times 12 over 2. 5 times 12 is 16, 60 over 2 is 30. So both methods, I found out that this ratio is equal to 30 square units in size. Okay, thank you very much.